All right, these are the video notes for 6.1 in Math 103, and I'm going to skip the first page of definitions, but we're going to go into what a like term is. So the important thing about a like term is that it has the same variable and the same exponent. So when we're combining like terms, we are simply putting the coefficients, the number in front of the variables together. So what we're essentially doing is taking 3 plus 6 and attaching the x. And so that gives us our answer of 9x. I want you to notice that the variable never changes. So if we are having x's and we are putting two x's together, they never become x squareds. They just remain x's. We can do addition and subtraction. So in this next problem, we are taking 5 and subtracting 2 and keeping the y to get our answer of 3y. Now, when we go to terms that are different throughout the problem, I usually use a system that helps me kind of keep things separate. I create a basket for all of my x terms, and I put those terms in my basket. So when I have 1x minus 8x, that gives me negative 7x. And everything has to be in a basket. So then I collect all my numbers. I have 3 plus 12, and that makes 15. And so I see I have two shapes. I have two baskets. I have two terms in my answer. I have an x term and I have a number term. When we go to the next problem, I'm going to do the same idea. I'm going to collect my x's. So negative 3x and positive 4x makes 1x. And I do not have to write the 1 in front of a variable. Then I go to my next term. I have 2 plus 10, and that makes 12. And then I go to my last terms. Negative 5y and positive 2y makes negative 3y. And it doesn't matter the order that you put those in. I am simply looking for the correct number in front of the variable and the correct sign. Now, using the distributive property, you are going to take this outside number and multiply it times everything inside the parentheses. And then eventually you're probably going to have to collect like terms as well. So I like to circle each of these, and as I circle them, I draw arrows so that I don't forget to multiply it by everything. So 3 times t is 3t. 3 times 3 is 9, and that removes the first set of parentheses. Plus 5 times t is 5t, minus 5 times negative 2 gives me negative 10. And then I have that plus 1. Now I'm going to collect all of my t's, and so I have 3 t's plus 5 t's, which make 8 t's. And then I have 9 minus 10, which is negative 1, plus 1, which is 0. Now, of course, I don't write the 0, but I wanted to show you that I do have two terms. I have a t term and I have a number term. So now I'm going to distribute. And notice what I do on this one is I circle the negative sign to go with it. And so I'm going to get 6r minus 18 minus 2r minus 10 plus 10. And so now I'm going to collect my r's. 6r minus 2r makes 4r. And then I have negative 18 and negative 10 makes negative 28, and positive 10 makes negative 18. Okay, you will have fractions as well as decimals, so the process starts the same. You're simply going to multiply this times everything in the parentheses, this times everything in the parentheses. So we get 0.2x plus 0.8 plus 1.2x minus 3.6. And now I collect my x's. 0.2 plus 1.2 makes 1.4x, and 0.8 minus 3.6 makes negative 2.8. Okay, so the last one, we're going to multiply again. So you'll probably need your calculators for this one. Multiply again. So when I take 0.9 times 2.3, I'm going to get 2.07x minus 1.8 plus, and 1.7 times 3.2 is 5.44x minus, and 1.7 times 5 gives me 8.5. And so now I collect my x's. 2.07 plus 5.44 gives me 7.51x, and negative 1.8 and negative 8.5 makes negative 10.3. So that's the process of collecting like terms. We are going to have fractions as well, and so you need to make sure that when you have fractions, you are going to distribute and make sure you remember your rules of fractions, okay? So we're going to take 2/3 times x, 2/3 times 6, 1/6 times x, and 1/6 times 6. So 2/3 times x is simply 2/3 x. I'm going to come up here, 2/3 times 6 over 1 gives me 12/3, which reduces to 4. And that makes it nice because now I have one less fraction, plus 1/6 x, and then I have 1/6 times 6 over 1, which is 6 over 6, which is 1. So remember, when I collect my x's, I have to have the same denominator. So I'm going to turn the 2/3 into 6 by multiplying by 2 over 2. So that gives me 4/6x, which I can now add to 1/6x, and that gives me 5/6x's. And then I've got 4 plus 1, which gives me 5. Okay, the next one we're going to do is we're going to distribute and distribute. Now, I like to circle the negative sign so that I don't forget that distribution. Now, if you would like, you could write it out like this for every term so that you, so that you can see what you're actually doing. You're just multiplying that fraction times everything in the parentheses. And then I get minus 1/4 times 2 over 1x. And then I get minus 1/4 times 5 over 1. So that might help you see some things. This is going to cancel, and so I'm left with 2x. This is going to cancel and leave 3, and I'm left with 2 times 3, which is 6. Now be careful on this one because the 2 cancels, and I'm left with negative 1/2 x. And then the next one, nothing cancels, and I'm left with negative 5/4. So now in order to put my x's together, I have to realize that this must be a fraction with a denominator of 2. So 4 over 2x minus 1 over 2x gives me 3 over 2x's. And then this one has to have a denominator of 4, so I'm going to multiply by 4 over 4 to give me 24/4, and then I'm going to minus 5/4. And 24 fourths minus 5 fourths gives me negative 19 fourths. And that would be my final answer. Okay, so the last thing I'm going to do in this section is just be able to evaluate expressions, and then I will do another video on how to solve equations. So evaluating an expression means that you are going to substitute the given value in for the variable to see if a true statement results. And so you must follow the order of operations. And I always replace the variable with parentheses. Okay, so that's the first step that I do. I come over here and I rewrite this as parentheses for x minus 7, and then that allows me to take this 4 and stick it inside the parentheses. And then I will calculate, well, I'm sorry, we're not trying to get a true statement. We're just trying to solve, I was thinking of an equation. We're going to substitute the given value and then we're going to, let's erase this, sorry. We're going to erase this and say the variable and then evaluate. Are you leaving? Okay. So we calculate 4 minus 7, and that gives me negative 3. Okay, so the reason I do this is because I want to make sure I'm very careful with my variable, especially when I have a negative sign. So I'm going to replace the x, leave the negative 3, and write plus 7. And now I'm going to substitute in negative 2. So negative 3 times negative 2 is positive 6 plus 7, and that gives me 13. Okay, so now I go parentheses for x squared minus 5 parentheses for x plus 12, and I replace the x with a 3. And so 3 squared gets replaced with 9, minus 5 times 3 is negative 15 plus 12, and so 9 minus 15 is negative 6 plus 12 gives me positive 6, okay? All right, the last two, I'm going to do the same thing. Parentheses for x squared plus 4 parentheses for x minus 7, and I'm going to replace the x with a negative 5. So negative 5 in parentheses squared is positive 25. 4 times negative 5 is negative 20 minus 7. And so 25 minus 20 is 5, and 5 minus 7 is 2. The one that you want to be careful of is when you see a negative in front of a variable that doesn't have a number, I want you to write that negative 1. So now that I do that, I'm going to have negative 1 parentheses for x squared plus 3 parentheses for x minus 10, and then I'm going to replace the x with negative 2. So now when I square negative 2, I get 4, but then I have to multiply it by negative 1, and that gives me negative 4. And then 3 times negative 2 is negative 6, and then I have the minus 10, and that's going to give me my final answer of negative 20.